So what we're talking about today is function rules, and there's four vocabulary words that we're going to learn, and that is sequence, term, arithmetic sequences, and geometric sequences. And a sequence is a list of numbers in a specific order, and then each number in the list is called a term of the sequence. And so for an example of the term, if you'll move your book down to, okay, right there. So this, you see the 11? That is a term. And then the whole thing is a sequence, okay? And I'm trying to make this even. Okay. Arithmetic sequence is when you can, the term can be found by adding the same number and then to the previous term. And then the geometric sequence is when each term is found by multiplying the previous term by the same number. So let's turn the page. Yes. Okay. So for the arithmetic and geometric sequences, underneath that it says, determining if a sequence is arithmetic or geometric can help you find the pattern. When you know the pattern, you can continue the sequence to find the missing number. So for example 1, I know y'all can see the blue, which has the answer, but we're going to work this one together. Okay, so the sequence that we're looking at is 7, 14, 21, and 28. So the question is, describe the relationship between the terms and the arithmetic sequence, 7, 14, 21, 28. Then write the next three terms. And as I said, remember, arithmetic is adding and geometric is multiplying. So if we have 7, 14, 21, and 28, we want to look at the first two numbers. So what do we need to add to 7 to get 14? 7? Okay. So if we add, I'm just going to use this. I don't know if you can see this. And excuse my handwriting. I have really bad handwriting. So if we have 7 plus 7 equals 14, and our first one is 7. Okay. So we have our first two numbers. To check to see if this pattern is correct, we have to add 7 to 14 as well. So it's 7 plus 14? Okay, and now let's check it one more time. What's 21 plus 7? So yes, the rule of the term 7 plus 7 is correct. That's the pattern. And the pattern is what you need to add or multiply to get to the second term. Does that make sense? Yes. Okay. And the question is asking, what are the next three terms? And so we know that the first is 7, the second is 14, the third is 21, the fourth is 28. So we're trying to find the 5th, 6th, and 7th. Okay? So what's 28 plus 7? So that is the 5th term. What's 35 plus 7? That's the 6th. And what's 42 plus 7? And there you go. We finished that one. And so the example explains it by... Can you see that? Okay. The example explains it by each term is found by adding 7 to the previous term. And then it just says to continue the pattern to find the next three terms, which is what we just did. And so let's go on to example 2. Yes. Example 2 says, describe the relationship between the terms in the geometric sequence. 2, 4, 6, 8, and 16. Then write the next three terms. So we're going to do the exact same thing we did last time, except this time it's asking for a geometric. And what is geometric again? Good job. Okay. So what do you have to multiply by 2 to get 4? 2. 2? Okay. if y'all can see that, but yeah. So 2 times 2 equals 4. 2 is our first. This is our second. Okay. So what do we, if we multiply 4 by 2, what do we get? If we multiply 8 by 2, what do we get? Cool. Okay, and then the question's asking, what are the next 3 terms? So what is 16 times 2? What is 32 times 2? And what is 64 times 2? So we found the pattern that the term times 2 gives the second term. Does that make sense? Okay. And so now we're down to the got it section. And so pretty much for the got it section, we're just trying to figure out what the pattern is. And so we know that our sequence is 0, 15, 30, and 45. And we're trying to find the pattern. So what do we have to do from 0 to get 15? Add 15? Okay, so if we add 15 to 0, what do we get? Cool. If we add 15 to 15, what do we get? 30. And if we add 15 to 30, what do we get? So is adding 15 the pattern? Good job. Okay. And then for the B one, we're going to go across. What you have is 4.5, 4, 3.5, and 3. So what do we need to do to the 4.5 to get 4? Good job. And if we subtract 0.5 from 4, what do we get? And if we subtract 0.5 from 3.5, what do we get? Then what is our pattern? Yeah. I know we didn't go over this one, and that's because it's not in here, but you can multiply, you can add, you can subtract, or you can divide to get a pattern. So it's not just multiplying and addition, and I should have told y'all that beforehand. But yeah. So what is the pattern for B again? Good job. Okay. And then I want y'all to do C and D on y'all's own. If you need like paper or something for y'all too, just let me know. There you go. You're welcome. And I'm going to give y'all like a minute to do it, so. If you need help, just ask me. If you need more time, raise your hand. Does everyone got it? Yeah. Okay, cool. So what did y'all get for C? What's the pattern for C?
Times 3.
Times 3. Good job. Okay, what's for D?
Times 2.
Yep. Okay, let's move on to 589. Let's go over these. Sorry. Underneath find a rule, it says a sequence can also be shown in a table. The table gives both the position of each term and the list and the value of the term. So the list is 8, 16, 24, and 32. And in the table, it'll have the position and then the value of the term. So the position underneath 1, it has 8. Underneath 2, it has 16. Underneath 3, it has 24. And underneath 4, it has 32. And then it says you can write an algebraic expression to describe a sequence. The value of each term can be described as a function of its position in the sequence. And the table above the position can be considered the input, and the value of the term can be the value of the term as the output. So what that means is that, so y'all are doing like x plus something equals another number, right? Y'all have done that, right? So if we look at this term, and we, our x right here is going to be the 1. So if we have 1 plus x equals 8, right? I'm doing this wrong, aren't I? Am I doing this wrong? It's been forever since I've done an algebraic expression. Okay.
Okay. So in this one, you can write the algebraic expression to describe a sequence. The value of each term can be described as a function of its position in the sequence. In the table above, the position can be considered the input, and the value of the term is the output. Okay, so remember we talked about yesterday your output and your input? Okay. The output's always what you get out of it. Input is what you put into it, right? Okay. So when you're looking at this, look at the value of the term at the bottom. The 8, 16, 24, 32. You know how she was showing you the pattern? You're looking for a sequence? Okay, so what sequence do y'all see going across the bottom?
Yes, right now.
What are you doing every time?
Times 2.
Times 2 every time, right?
Yes, ma'am.
Okay. Okay, well let's look at something real quick. You said 8 times 2 is 16.
No, wouldn't it be addition?
Okay, so let's look at that. Okay, so let's do 8 plus 2, or excuse me, 8 times 2 is 16, right?
Yes, ma'am.
But 16 times 2, is that 24? No, so you back up now, so let's try something else. So what else could you do? Add 8, let's try add 8. So 8 plus 8 is 16. 16 plus 8, is that 24?
Yes, ma'am.
Okay, so which one will be our pattern?
8. Add 8.
You're going to add 8 on there. Okay, so let's go down to example down below it then, and let's see how we can apply that.
Yes, thank you. So underneath example 3 says, use words and symbols to describe the value of each term as a function of its position. Then find the value of the 10th term. So our positions are 1, 2, 3, 4, and n. And then our value of the term is 3, 6, 9, 12, and then we have a blank. So if you notice that the value of each term is 3 times its position number, so the value of the term in position n is 3n, right?
Yes, ma'am.
Okay. So now we need to find the value of the 10th. Yes.
Okay, see what we're doing?
Yeah.
So now we need to find the value of the 10th term in the sequence. Oh, wait. Yes. Now find the value of the 10th term. So we know that 3n equals 3 times 10, right?
Yes, ma'am.
Which equals 30, right?
Yes, ma'am.
So, do you know how we got that number? Like, do you need me to explain it?
Yes, ma'am.
Yeah? Okay, cool. So, the best way to do this is look here.
This looks how good to the back.
Okay. So we know that this number right here times 3 will give you this number, right?
Yes, ma'am.
Can you see? Okay. So this number times 3 will give you this number. So we know that 2 times 3 is 6, and 3 times 3 is 9, What's 4 times 3?
12.
What's 5 times 3?
15.
What's 6 times 3?
18.
What's 7 times 3?
21.
What's 8 times 3? What's 9 times 3? What's 10 times 3? So that's how we got this number down here. They just made it more simple by knowing that they asked for the 10th term, so they already knew that this number was going to be 10, and they knew the pattern by multiplying that by 30, okay? Let me keep this simple. So let's go down to got it. And I underlined the 8th term when I was studying this, just because that's important. Like last time they asked for the 10th, this time they're asking for the 8th. So it says, use words and symbols to describe the value of each term as a function of its position. Then find the value of the 8th term. So remember, the top is our position, and the bottom is the value of the term. So, what do we have to do to get 12? Times 6. Does that work for all of the positions?
Yes, ma'am.
So what, how do we get to the 8th term? And what do we do to the 8th term to get, let me rephrase that. So we have 2, 3, 4, 5. We need 6, 7, and 8, right? So what would be the 6th value of term?
36.
What would be the 7th?
42. 42.
And what would be the 8th?
49.
49. So that, yeah. Okay, so the 8th term, I don't know if this is highlighted. So we have the 6th is what? What was the 6th again?
36.
What was the 7th?
42.
And what was the 8th?
48.
48. Okay, and that's how we got the 8th term from the position. Does that make sense to everyone? To everyone, give me a high five, or give me a 5 if it doesn't make sense. It doesn't make sense? Oh, the fist of 4
Do
thing?
a fist of 4. One means let's see, one means you need some help, right? You're not getting it. What does 2 mean?
2 means we're kind of not getting it, but we still need some help.
Okay. And
3
3
means we're kind of getting it, we not
you
it.
got it. 3 you got it.
Could help someone if
No, 4 you got it. 4 you can help. Yeah, you got it.
And then, yeah, so 3
Oh,
you
okay.
got it. 4 is I know it so well I can even help somebody else if they need me.
Yeah.
Okay, good.
Okay.
So give her a fist of 4. Okay, so 3s and 4s tell us that we're good to go and we're kind of ready to move on a little bit. We're ready. Okay?
So can y'all do F by yourselves? Or you can do it with a partner if you need to. And remember, we're trying to find the 8th term.